In this video, we'll prove why the derivative of natural logarithm of x, ln x, is 1 over x using the limit definition of the derivative, also known as the first principle. To do this, we'll utilize the limit definition of a derivative formula and the definition of Euler's number shown below the screen. Let's first write down the statement we want to prove and the necessary formulas. Here we have the limit definition of the derivative formula and Euler's number. Let's define f of x as ln x. Then f of x plus h will be ln x plus h. By substituting these expressions into the limit definition of the derivative formula, the numerator becomes ln x plus h minus ln x, and the denominator remains as h. Looking at the numerator, we can simplify using the logarithmic property of subtracting logarithms as ln x plus h over x. We can rearrange the denominator by expressing h as a fraction, allowing us to move 1 over h to the front of the logarithm. And if we express the fraction inside the logarithm as two separate fractions, x plus h over x can be rewritten as x over x plus h over x. Since x over x is equal to 1, we can simplify the expression further to the limit of 1 over h times ln 1 plus h over x. Now, let's move the 1 over h that was multiplied to the natural logarithm to the exponent position inside the logarithm. This gives us the limit of ln 1 plus h over x to the power of 1 over h. It looks similar to the Euler's number shown in the top right corner of the screen, but it requires further manipulation. Therefore, let's substitute h over x with n. As h approaches 0, n will also approach 0. Multiplying both sides by x gives us h equals nx, and taking the reciprocal of the expression gives us 1 over h is 1 over nx. By substituting all occurrences of h with n in the above limit, we can express it in terms of n approaching 0. The expression h over x inside the natural logarithm becomes n, and the exponent 1 over h becomes 1 over nx. Rewriting the exponent 1 over nx as 1 over n times 1 over x, the limit becomes n approaches 0 of ln 1 plus n to the power of 1 over n to the power of 1 over x. Taking the exponent 1 over x outside the logarithm using the properties of logarithms, we get 1 over x times ln 1 plus n to the power of 1 over n. And the 1 over x term is independent of the limit as n approaches 0, so we can move it back in front of the limit. Thus, the expression becomes 1 over x times limit of ln 1 plus n to the power of 1 over n. Since Euler's number e is defined as the limit of 1 plus n to the power of 1 over n when n approaches 0, we can replace the limit with e, simplifying the expression to 1 over x times ln e, which is equal to 1 over x. Therefore, we conclude that the derivative of ln x is 1 over x. Today, we have demonstrated why the derivative of the natural logarithm of x is 1 over x, using the limit definition of the derivative and the first principle. Now you can use the proven result to find the derivative of logarithmic functions. On my channel, you'll find many videos covering the proofs of derivatives of various functions and quick method to perform differentiations easily. I believe they'll be helpful for your learning. I want to express my gratitude to all of you who watched today's video. Your subscriptions and likes bring great joy to me. Thank you once again, and I will see you next time. This has been your Math Guardian, Alex.